So friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with the computer-based numerical and statistical technique. This has been the class 2, and as you know that we had started with class 1 in the last classes. In that we had even started with computer-based numerical statistical technique, where we had implemented the add of the following and the subtract of the following as well for the floating point numbers, both for that. Now today we'll discuss about to multiply the following two numbers, and we'll divide, we'll do that as well. That has been another question. Before starting with this, it's a huge request to all the viewers to please go through with the subscribe button and please like, share and subscribe to our channel so that many maximum people can get the information at once, and even you can also enjoy the video as well. So thank you for subscribing us. Thank you for make us reach more than 3K, and please keep supporting us as you had supported till the date. Let's go ahead for the same here. Question of the session. Question is, multiply the following two numbers, 3.1897 E10 and 0.18631 E11 that we have. So here multiply the mantissa and add the exponents here. So for the same we'll go ahead here, and that we have, so which is been as follows: 3.1897 E10, 0.18631 E11 equals to 0.594273 E21. This is your add exponent, and this is your multiply mantissa. Here, so that we have here, that has been the answer. Now we'll go ahead for the next. We'll evaluate for the question as well, which has been important. Evaluate 41.9875 E16 upon 378.1619 E11. So for this has been the question, that is for using the division method that we have to focus on. So here we will divide the mantissa and subtract exponents as well. So result we will get 01.9875 upon 378.1619 E 16 minus 11, so which will be equals to 0.11100304 E5, and further it is equals to 0.11100304 E5. that we have your answer as well. Let's go ahead for the next question that we talk about it, which has been another important question. Addition of small and large number. Add the small number 0.0010 to large number 4000 using a computer with 4-digit mantissa and 1-digit exponent. We'll go ahead. Addition of a small and large number. Add the small number 0.0010 two large number four zero 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 using a computer with 4-digit mantissa and 1-digit exponent. So we'll solve for the same here. Let us first normalize the number to 4-digit mantissa, which is being your 4000. It will be 0.4000e4, and another one is 0.0010. It will be 0.1000e2. Since we have to perform an addition, the exponents of the two numbers must be made equal. In such case, we make all exponent equals to the highest exponent, and here we have to make exponent of second number equals to 4, and that is that is we'll get here, and for the same we'll just go ahead for the same, and that is being as follows: 0.100 e2 is 0.000001 e4. Now let us add the two numbers, that is we have 0.4000 e4, 0.000001 e4. It will give 0.400001e4 that we have. So in the case that the result that must have 4-digit mantissa, and hence rounding to the 4 significant digit above results become, and in the same cases it will become 0.400001 e4 is 0.4000 e4. Now this is equals to the first number only, and this result shows that the errors can be introduced when large numbers and small numbers are added here. I will go ahead for the next question here, and that is being the important one as well. So we'll go ahead for the same. Question is, show that associative and distributive laws are not valid in normalized floating point arithmetic with the help of the following example, and that we have a distributive law: ab minus c does not equals to ab minus ac, where a is equal to 0.5555 e1, b equals to 0.4545 e1, and c is equals to 0.4535 e1. So for the same we have to talk about it, and that even though we have to go ahead for the further, let's move ahead here. Show that associative and distributive laws are not valid in the normalized floating point arithmetic with the help of following examples. First we have here, that is for distributive law. What it is: a b minus c does not equals to ab minus ac, where a equals to 0.5555 E1, b equals to 0.4545 E1, and c equals to 0.4535 E1 that we have. So now we'll do it. This was non-distributivity of floating point arithmetic. So A is this, B is this, and C is this. So we'll go ahead for the C. B minus C, which we have here. As you can see, the distributive law. B minus C, will find it out. That's B 0.4545 minus B is this, minus C is your this 0.4535, and we do both have a common E1. We'll be having a common E1, which is equals to 0.001 E1, and it will be represented by 0.1 E1 minus 1. Now we'll talk about for A, B minus C. B minus C हमने निकाल लिया. अब A इसको मल्टीप्लाई करेंगे. What we'll get 0.555 and 5. This is your, we have E1 multiply 0.1 E minus 1. What we'll get 0.5555 into 0.1 E 1 minus 1. Further it is 0.0555 and 5 E 0 equals to 0.5555 E minus 1. Now we'll find out for the value for AB here. For AB it is now AB, that is B in AB equals to A multiply B here, so 0.5555. This is your A, this is your B, that both will multiply here. E1 multiply 0.4545 E1, it will be 0.555 and 5 E1. It will be 0.5 that we have here multiplied even, so it will become, now we'll just take it out, so it will be multiply 0.4545 E and 1 plus 1, which is equals to 0.2524 E2. Now we'll go ahead for finding it out. AC here, that has been representing here as well. So for AC it will be 0.5555 E1 multiply 0.4535 E1. When we multiply both, here we get 0.555 and 5 multiply 0.4535 E1 plus 1 equals to 0.2519 E2. Now we'll go ahead with finding it out AB minus AC, and for the same we'll go ahead here as well. Let's go ahead for the same. For the same here, we'll go ahead for AB minus AC. It is equals to 0.2524 E2 minus 0.2519 E2, and which is being equals to 0.2524 minus 0.2519 E2 equals to 0.0005 E2, and that is equals to 0.5 E minus 1. Now equation from 1 and 2 shows that 1 will be A B minus C wala, and that is the second equation, of course, this one. These shows that A minus AB minus C is not equals to AB minus AC. Now we'll go ahead for the next question. We talk about it, and that has been here for the associative law, which is of second one. In terms of associative law, it will be A plus B minus C does not equals to A minus C plus B. And for here it is A equals to 0.5665 E1, B equals to 0.5556 E minus 1, C equals to 0.5644 E1. Now for that we'll have to find it out. Non-associativity of floating point arithmetic that we have, where A 0 this, B and C in this. So we'll find out for A plus B, which equals to 0.5665 E1 plus 0.5556 E minus 1. This equals to 0.5665 E1 plus 0.0055556 E1. It will get 0.5665 plus 0.0055 and 56 E1, which is equals to 0.5720 E1. This we have. Now we'll go ahead for the A plus B minus C here. I will go ahead for A plus B minus C, as I told you. A plus B minus C. For that it is 0.5720 E1 minus 0.5644 E1. Then it will be your 0.5720 minus 0.5644 E1, which is equals to 0.0076 E1, and that will become 0.76 E minus 1. This is becoming the third equation. Now we'll go ahead for the next. We'll find out for A minus C. A minus C will get here 0.5665 E1 minus 0.5644 E1. It will be 0.5665 minus 0.5644 E1 is equals to 0.0021 E1, and that is being equals to 0.21 E minus 1 here. Now we'll go ahead for the next. We'll talk about it, which has been another one as A minus B plus C. We have so A minus C and plus B we have here, and the same cases with this 0.21 E minus 1 plus 0.5556 E minus 1 equals to 0.21 plus 0.5556 E minus 1 equals to 0.7656 E minus 1. This is becoming the fourth equation. So equation 3 and 4 that shows that A plus B minus C does not equals to A minus C plus B here. Now we'll go ahead to find out and to talk about types of errors that we have here, which is being important too. We'll discuss here types of errors that we have. In same case for the types of error, where the first error that we have is the truncation error. We'll talk about it. First error we have is truncation error. that we have in truncation error, that it is generated because of taking only significant digit and discarding the remaining ones. I will just write it down for those who are new in while studying this. It is generated because of taking only significant digits and discarding the remaining ones. Now talking about the second error, which has been the rounding errors, we have that has been the rounding errors. We have in same case for the rounding errors we discussed here. It is generated because of the rounding of the last significant digit. So it is generated because of rounding the last significant digit to nearest value. So absolute error we have absolute error, which is of E of A is equals to true value minus approximate value. Now for relative error we talk about it. Which is E of R is equals to in the same cases we have your absolute error upon true value. You can just here you can see that absolute value equals to true value approximate value. So इसमें relative error चाहिए था मुझे. So what we had done is absolute upon true value. That will be the relative error here. And now we'll talk about the absolute error in a summation. That how will we write it down? That is your absolute error in summation. So for that we have your formula as E of A is equals to EA1 plus EA2 plus EA3 plus EAN here that we have here. Okay, now for the next we'll talk about it here in the detail about it. We'll talk about the absolute error in product. This is for the summation that we had discussed. So now we'll discuss about for the error as well. For absolute error in product, so for that we have here is your equals to AEA2 plus BEA1. For absolute error in division we talk about it. In division, in that EA equals to BAEA1 minus AE2 b square. Now we'll discuss about the inherent error. Inherent error here. In inherent error, this error is present in the statement of the problem itself before its solution is obtained. This error arises because of the following reason. The first reason, we have error in physical measurement of parameters, which is error in physical measurement of parameters. Second, we have here the second reason, approximation of the problem based on simplified assumption. Approximation of the problem based on simplified assumption that we have. Now we have another question here, that to define and explain the truncation or chopping error, that even though we have to talk about it, so we'll go ahead for the same. Define and explain truncation or chopping error that we have. In same case for truncation or chopping error, here in this, that the definition of truncation error, as I had told you, even though I had made you write as well. So truncation errors are generated when only required significant digits are considered and remaining are discarded. Example, like you have to consider the value of 1 by 6, or true value of 1 by 6 is 0.1666. So I just go ahead for the same. So if you have imagine the value of 1 by 6, so here true value for that is equals to 0.166666 until infinite. And if our computer represents only 6 significant digits after the decimal point, then the above value will be of approximation is of course 0.1666. 1 times is 1 and then 0.6666. So here you have to note that only 6 digits after the decimal point are considered and remaining are truncated or chopped, and hence error will be. So we'll find it out for the same is error D is equals to true value minus approximation value. So true value we have is 0.1666666666 minus, this is infinite, 0.1666 and 6. So we'll get your value here, which will be 0.00000666. This we have. So here ET, that means this is ET, that means the true errors, and note that the truncation errors obtained above and also in finite significant digit, where the truncation errors is also occurs in the series expansion. For example, e of x, that e power x, cos x, sin x, etc. terms as evaluated in the computers by series expansion, and these series contain infinite numbers of terms, but the computers can evaluate only limited number of terms in series, and hence truncations of series is done, and this introduces the error in the value that being evaluated here. We're going ahead with end up with this, and it's a huge request to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than this, we had done your 2 classes of CBNST here, and after talking about that, we had done your sociology and software engineering. We had done your chemistry as well, where we had done in your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, and unit 8, unit that 9 we have done. With the same, we had done your conversion, we had done your conversion, logarithms, antilogs, element symbols, atomic mass, atomic number, and molar masses as well, with the electronic configuration. After talking about that, we are dealing with understanding the human being comprehensively, the human aspiration and its fulfillment, and with the 2 marks possible question as well. And after talking about that, we are dealing with the ER diagrams, which has been important for you all. After talking about that, we are dealing with reasoning, where we had completed your verbal reasoning. In that, we had done your general mental ability in the logic reasoning. In non-verbal reasoning, we had done your series analogy, classification, analytical reasoning, mirror image, water image, and mirrored figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, and practice question set that we are dealing here right now. After talking about completing that, we'll surely start discussing about the another new subject related to the competition wise. In terms of quantitative aptitude, this has also been divided into two sections, which will be in the arithmetical ability and the data interpretation. In arithmetical ability, we had down your operations on numbers, LCM and SCF of number, decimal fractions, simplification, square roots and cube roots, problems on numbers, percentages, stars and indices, and percentage we are dealing here, where we had to teach more than 200 question of course. In terms of computer-based numerical and statistical technique, here we had started with unit 1, which has been divided into two parts. It's computer arithmetical error and roots of equation. In computer arithmetic error, we had done your floating points and arithmetic machine, Appleton's round off error, chopping error we are dealing with. Truncation error we had started with, and after completing associated distributive law of floating point, arithmetic inherent error, errors, propagation, numerical instability. After completing that, we'll start discussing about the roots of equation. We have to complete the second method and the Newton-Raphson method and the fixed point iteration method for the simple roots and derivations on the rate of the convergence. And then we have to take an accelerations of conversion, modified Newton-Raphson method for multiple roots, Bridge-White method for the polynomials, and your Weierstrass method for the quadratic factor, computer algorithm of these factor methods as well. In unit 2, we have to cover up that has been the interpolation. Here we have to cover up the algorithms and the error analysis of the Lagrange and the Newton's divided differences, interpolation, relationship in the various difference operation, piece-wise in linear interpolations, cubic spline interpolation, as well as spline. And then we have to deal with the Chebyshev polynomial approximation, and then Langkow's economization of the power series. And in the curve fitting, we have to do with linear and non-linear least squares approximation. Then third condition in the least squares method, that is Abraham-Smith problem, process of orthogonalizations, computer algorithms at least square curve fitting. In unit 3, we have to cover up that is the differentiation, which is method based on the interpolation and finite differences, Ricciardo extrapolation. In integration error analysis of the trapezoidal and Simpson method, Newton's coarse integration method, Gaussian integration method, Gauss-Legendre method, and Lobato integration methods, and Randall integration methods, and error termed in the integration method. In unit 4, that is the solution of simultaneous linear algebraic equation. We have to do with the Gauss elimination method, third conditional system, conditioned systems, condition number, successive and relaxative method, rate of the conversion, solution of ordinary differential equation, single step method, Rangekutta second order, that is your third order, and the fourth order method, that multi-step method, and predicative corrective method. Statistical techniques, we have to do with the statistical hypothesis, test of hypothesis, type 1 and type 2 errors, level of significance test involving normal distribution as well. So here we're gonna end up with, it's a huge request to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please keep us supporting us as you had supported till the date. Thank you.